Everyone. Yes, in this video we are still continuing with the normalization chapter. We have seen our first normal form, second normal form, and third normal form so far, and have broken our relation or table into four separate relationships already. And this is how it looks. So for improving the design, always the normalization is useful because it helps eliminate the data duplication, and we have to always be sure about the primary key assignments and naming conventions, and while deciding, what are the attributes, whether they can be further divided or not. So to be sure about it, you have to emphasize on atomicity, or atomicity means the characteristics of an atomic attribute. So let's say the name of an employee, the first name and the last name, it cannot further be subdivided, correct? An address can be subdivided into apartment number or area, the state, city, and the zip code. But if you want to divide the first name of an employee, so this is atomic, it cannot be further subdivided. This is something we need to make sure about. Then, while deciding primary keys, also we need to get into detailed explanation about how we are defining the primary keys. That's all. Let's move on to the Boyce Codd normal form, or BCNF. So, what are the rules of BCNF that we have to be sure about? So, first, it should be in the third normal form, as it says, and for all, each and every functional dependency in the relation currently, A should be a super key, not a primary key. It should be a super key. Okay. So here, the second point sounds a bit tricky, right? How to decide a super key, correct? How can I say that this attribute is a super key, another one is not? So in the simple word, it means that this is the rule for it. Here comes your non-prime and prime attribute. So in a functional dependency, it tends to be A cannot be a non-prime attribute if B is a prime attribute. So this is the rule that we have to make sure for the second one. Either you can go with this, or you can make sure that this one holds true for your relation. A cannot be a non-prime attribute, and if B is a prime attribute. So let's see this example here. Okay, so for this relation, okay, student ID, subject, and professor. So this is a college enrollment table with all these three columns. So just look at the table and think about what are the functional dependencies here. You see some of the duplicate data are all available in all of the three rows. So can I say student ID and subject both together can determine professor? Yes, we can say that. Can I say professor determines subject? Can we have another functional dependency? Professor tends to subject. Yes, we can do that. All the professor individually identify the subject, all the rows. So from this we can say that from these two functional dependency, our student ID subject is a primary key. Okay, got an idea? So let's make sure, okay, um, that the table, whether that to make sure the table is in your first normal form, second normal form, third normal form. So we have to make sure that whether we have atomic values for first normal form, yes, that holds true, it satisfies. For second normal form, does it have any partial dependency? No, this is a primary key. Professor is not a part of primary key, so no partial. And does it have a transitivity? No, it doesn't look like it has a transitive dependency. So here, can we say this is in third normal form? Yes, this is in third normal form. So now the condition is that we can move on to the BCNF. So as the BCNF says, it should be third normal form. First one satisfied, but either of both these two condition one should hold true. The super key one and the prime non-prime one. So see, the table isn't in the BCNF. Why? Because we have a functional dependency professor tends to subject, correct? This one. So as per our rule, as it says, if A tends to B and if B is a part of a primary key, then A can never be a non-prime attribute. Okay, so professor isn't a prime attribute, but subject is a prime attribute. Subject is a part of a primary key. So this one discards our BCNF rule. So and it denies the BCNF. So how to satisfy the relation into BCNF now? How to satisfy? So to make the relation satisfy the BCNF, now we have to break the table. So how to break the table? So based on these two functional dependency, you need to break the table. So if we can do like this, um, for which one is denying our rule? The professor tends to subject, correct? So what we can do, if we can divide the table into this structure. First student ID, and there we need another one third attribute also, PID. Okay, and a new key, that is the PID, is needed to be added to both the table. So as there are two functional dependencies, student ID, subject tends to professor. Let me write it here, it will be easier. Okay, so let's see. This is one of our functional dependency, and there is another one initially. As the condition denies the BCNF, so to make this relation satisfy BCNF, we will decompose the table into these two tables, student and the professor table. So here is the resultant structure, and we have to make sure that a new key to be added to both the tables. Why? Because the professor subject, this functional dependency that doesn't satisfy the BCNF, as subject is a prime attribute. So professor can never be a non-prime attribute. So as it denies that, take these two and make it one relation. But we need to have some sort of relationship in between the student ID and professor subject, correct? So the professor subject will be added with another one temporary column PID, suppose, and PID will also be allocated to the student. And these two tables, if we take this, consider this one, let's say PID tends to student ID, it's in BCNF, okay, and we can say that PID is our primary key, and PID professor subject. So can we say PID determines the value of professor subject? So both of these relations and their functional dependencies are not denying the BCNF rule. Now they are in the BCNF. Let's see our. Let me make another one video for the fourth normal form. It will be, or else it will get too much longer.